and welcome into Generalizing. And today I can't afford to play Doom Eternal. I don't have any more money left for it. Yes, I can't afford to play Doom Eternal on streams anymore because, well, off stream I don't play Doom Eternal off stream, so I just can't afford to play it. And so today we're just gonna do some walk, walk on the videos, walk on maybe a short, maybe the website, just a bunch of different things that we can walk on. Hi Detha, hi Timon, hi Demon, hi Rachel, hi Catman, hi. Why is the three of you? Because I need to be more productive. I need more hands on deck. Making streams have run back to time when I wake up. Oh, how perfect! Wait. What time is it right now? You wake up really early in the morning. Oh yeah, wait, hold on. Oh right, it's the work week. I forgot. I forgot, never mind. That makes sense. Yeah, right. All the people are productive members of society. I keep forgetting. And so today, I guess we can walk on the video, make it short. Walk on the website, as I mentioned. We'll see. We'll see what happens. Okay. So, I need to turn off everything that's unrelated because I don't want to spoil anything. You okay? Okay. So, with the quantum mechanics video, where do we finish off? That's a good question. I do believe we finished off with a wave. When I was describing the difference between physical and mathematical waves. For the purpose of the video. Well, technically there isn't much of a difference, but in practice, when we're talking about waves in mathematics, we're talking about the cosine or sine, and cosine or sine are waves that go over the entire real number line, whilst in physics it is different because waves are localized. They don't actually go forever. Do make it build up in part 2. I don't have a budget for that. I've already mentioned it. I don't have a budget for that. I would need money for that one, which I do not have. Did you switch to live chat? I didn't yet. I will in a second. This, correct? Oh, for some reason it's not opening. Well, that's curious. Open. Don't save. Waves. There we are. How much? That's a good question. How much money will I need for this? Well, I imagine like... Hold on, let me get a rough estimate. Considering how I don't have a workshop, I need a whole bunch like this. That one will take at least a month. This $1,400, maybe $1,500, something like that. Something in this rough area, probably. Yeah, anyway. Now, let's get back to the video. What point did I finish off? Because the real numbers with description, we always this void, that's this is a wave or this or this, and this, right? Well, let's expand the concept. That's because a wave is more like a way of analyzing conjoint things out. Okay, that doesn't make sense, but let me explain. Take a look at this wave function. You can see a clear wave number which can measure and figure out, except there's a pickle. Measurement of the wave number is not seamless because if we have a cosine number 2, here's a wave number of 0. Okay, so what we want right now is we want what? A wave. Possibly save it as a new one. Hi, the Red Blacks. Hi, welcome. Going to the office and crying my advisor about how to choose a hat, and I don't like him. Oh, piss. In this one, we want to expand the Gaussian, which will mean this, correct? Yes. Alright, 7 seems fine. Hi, Timon, hi. 6 right here should be fine. Okay. Oh, piss, I shouldn't have done that. It's actually a much better way would be just do it with an animation. Like 600. These animations are really quick because there isn't much going on. 7.5. Oh, I love how these look. Oh, this is great. Okay, now we're under animation. And I made it high. No, let me have a sip of coffee because I can feel myself being slow.
No,
Okay.
yeah, I made it can't join anymore.
Yeah, because the rank expired.
Said I promised made it that I would scream at them, but now I can't. Oh yeah, Catman says I'm still quiet, apparently.
Still quiet? I need to. All right. Well,
Like, you killed my
now you are on.
volume.
Now you are on 200 on Discord. That's
Oh,
the
jeez.
maximum. I can't put you any higher.
But you killed my volume when you were playing Doom.
No, I didn't
That's
actually.
You didn't, but...
No, that's how you were when you joined in.
Ah. I don't know why I was quiet.
Actually, it's not that I don't like charts. Like, to be honest, the idea is very smart, but working with rigorously is... I always found it counterintuitive, because I always thought that charts are... Unless we're talking about different kinds of charts, but I always thought that the idea of analyzing charts was really weird, because charts, they're meant to just give you the rough idea so that then you can see where to look. At least that's how I always use charts, I know. Yummy. This and this and this. This. No, I'm talking about charts. Yeah, that's exactly what I'm saying. I remember because I mean that's because I'm pretty certain that topic isn't introduced that late. Actually, I do believe in primary school. Wait, is it in primary school? The international education system's always screwing me up. In one of them schools, it's introduced where basically you have different charts of mathematics, and based on that, you're supposed to solve it. I don't know, it's been fucking decades. The risky coordinate system of manifolds. Differential geometry in primary schools. I don't know the education systems cross country because there isn't an international standard. It always pisses me off. Like, for example, in Hungary, do you have colleges, Timon? A college. Does that exist in Hungary?
I'm not like what?
A college.
Like, I'm not sure what college is. Like, the American terminology always confuses me.
Well, it's not really that the American terminology confuses you. Only is that in, as far as I'm aware, in most countries in Europe, there are no colleges. They just don't exist. Because college is like a...
What does college mean then?
Well, you know the universities we have in Europe?
Yeah.
Basically, in America, they're like kind of broken down into two parts, where the simpler one is the college, and the more difficult one is the university.
So basically, as if the bachelor's and the master's was done in different institutions.
But I'm pretty certain bachelor's and master's is still done in universities in America. That's the whole, is bachelor's and master's I don't know how, it's confusing.
So like college is like a higher college and university are both higher education.
Yes.
It's just a different type of higher education.
Well, not different type, because normally you go to college to then go to university.
What? But then why? But if bachelors are done in university, then why can't you go to bachelors right after high school?
I don't fucking know. That's why it's so confusing to me always. As far as I'm aware, it goes, I'm pretty sure college and university is a private versus public distinction sort of thing. Is it? I don't know. I'm gonna look it up. College versus university. College's undergraduate education of associate and bachelor's degree. Okay, so we can get the bachelor's in college.
Mm-hmm.
Universities have a stronger research component. US news, I suppose if I'm gonna trust someone, it would be US news, right?
So college is only for education and university is for both education and research. University is larger. I mean,
Yeah, college is smaller. And universities are larger. Yeah, no. Because to me, it's always been called just the university. That's how I, at least, that's what I always called it.
Yeah. If people ask me if I'm a college student, I don't know what I should reply to because I feel like they mean what I feel like they mean what I am going through right now, but it's still called a university and not a college. And I never knew the difference.
That's certainly quite a pickle. Ooh.
In France, college stands for middle school. All right. In Hungarian, the word collegium stands for a place where the students live, but it's not like an institution or anything. It's just a big house where they stack students. So they have places to live. Some of them at least.
Oh, I need a sip of coffee. Yep. That's how I always just enter, but I don't, it's confusing. There should be some kind of standard. Hi, Dorothy. Yes, the wave number which can measure and figure out if there's a bigger measurement is not as clear as it seems. Okay, so for this, we have this one. We have a clear wave number which we can measure and figure out, which means right here what we'd like is a cylinder.
One other thing that is weird for me is like when people ask me if I'm a physics major and I have no idea what that means.
Oh, the titles.
You know, I don't know, like, I think they mean that in a bachelor's, but like...
Major as a person that graduated, right?
No, I think that... I have no idea. I genuinely don't know. And they, like... Often it's be like, you're a physics major, right? As if they already knew it, just want me to confirm it, and I have no idea what that means, like, what that means.
When you major in is what you are going to graduate as. Okay, so a physics major is... Wait, so is physics major someone who's graduated already or someone who's going to graduate in a field of physics?
Going to graduate as, so
but that's what you major in. You're majoring in the thing you're going to graduate. But when you are a physics major, does that mean you already graduated? Or not? Oh, pissed. I said the wave number to be 2. Where's the wave number? Oh, when these geometry nodes the wave number. Cosine phase. Oh, I think that's the wave number. It's 1. Should be 2.
So
Well.
when you're majoring, you're studying. So yeah, I guess I am a physics major, apparently. Good to know. Bye.
Oh, I like these. I like these wave animations. They're so funky. How much did the total end up at? For the Doom one? I'm assuming you're asking the Doom one. $145. I did not in fact beat it. But to be fair, $70 came from a single Slayer gate, so... and which is the reason why I didn't beat it.
Once you graduate, you have a major, bachelor, PhD of other forms of degrees in physics. Wait, what's the difference between major and bachelor's then?
Isn't bachelor's the next step? Nice to see you get along with the fairy, yeah.
Yeah, I'm not a furry. Like no, bachelor's was the first step for me. Like after high school, I started bachelor's, and that wasn't anything in between. So like, what do you mean? So
I'm guessing. I don't know. What do you mean? What do I mean? I don't have any formal education. How am I supposed to know? I'm guessing. Bachelor's is smaller than master's. That's.
Yeah, I know that, but like, first bachelor's, then master's, then PhD. Like that is how it goes in. Yeah, but
Because
like,
associates, bachelor's, majors, doctorates. I see. Is professor a formal one or an informal?
I have no idea.
Let me check.
I think it's formal.
Who ranks above an associate professor? An academic rank at universities. Oh, it is formal.
Because
Formal-ish?
bachelor's, major, doctorates. Okay, but like, where does masters fit in, and what's an associate? Like, I'm literally doing this, but like half of these things just don't just don't exist here.
Oh my goodness, on Wikipedia, such a menace. They just list all of them, all the countries they could find. Okay, I'm just gonna pick. What is it? Netherlands. Good pick. Never mind. There's a different article for Netherlands. I take it back. UK, United Kingdom. Okay, so in the UK there is the many. Okay, research and teaching. Okay, so for research, okay, I take it back. United States, maybe, I don't know. So you mean to tell me there is no standard international system of academic ranks? Why? I don't understand.
What Reblex is saying is exactly how it goes in Hungary, so yeah.
It's basically a job title, what you get in the university. Why need one? Well, why need an international system? I don't know, because science is kind of universal. I mean, if you got a certain education in, for example, the Netherlands, then I'm pretty certain if you're applying for a research grant, let's say, in the UK, then I guess then should the academic rank matter? It feels just weird for science to not have a standardized system for academic ranks.
Make it Remco is talking to you in the memes channel.
What? Why?
They are talking about nail polish to you. For yeah, they want you. They want you to know their opinion on nail polish.
Cool. Great. Glad to know. We are still using imperial units. What do you expect from us? Funny enough, actually, well, I mean, as far as I'm aware, every single country in the world that uses imperial units still doesn't use them in science. Unless I'm mistaken. Yeah. Every single scientific organization in the world uses metric. Yeah. Or sometimes they go even more specific, but that's a whole other story. Which, I mean, metric still sucks. I'm still willing to die on that hill. Use metric for science. What am I doing? Oh yeah, right, I'm doing this. Wave. Oh, this is a fun example. Then the main weird thing in the US is that PhD programs are freaky. I guess I understand you enter such a program right after your bachelor's.
Whoa.
I always feel so alienated whenever anyone talks about academia. Like, I get it. Everyone here is looking for a path into academia, or eventually getting a doctorate or something like that. But as someone with no formal education, it just feels weird.
I think most people who stumble across your channel, I think that you have at least a bachelor's in physics.
Everyone here is gonna be jobless. No, I'm gonna be the only one. It's more recommended that you get a master's before pursuing a PhD, but in America you have the freedom to do it after a bachelor's. Damn. All of us Europos just got owned. Yeah, we're just crying in unity. Politics! Speaking of, Germany's election happened. It's curious. Because it's not as bad as it could be. as far as I'm aware, CDU is still extremely anti-working with AFD, and they might actually. I think the Grand Coalition actually has enough votes to be viable, which is good. That's actually good news. Gemma elections. I feel like learning academia has a better chance of me meeting ends meet and doing whatever your money making method is. I mean, I support it. I do think that going into academia is much better than not going into it. The only problem is, as I mentioned, I can't specialize. I don't know what I would need to specialize in. If I actually had something picked, if I could pick something to specialize in, I would go into academia.
Make it. I've already like that. I have a good recommendation. The place I picked out that I already told you about. That's basically that's literally for people who are unable to specialize, so they can just pick out whatever they want.
Yeah, and you're getting a bachelor's in what?
I don't know. Something apparently.
Looks at the election results for Germany like I know any of the parties. I know AFD, but that's about it. Don't worry, I can explain. Allow me to. me. So basically, you have the CDU-CSU, which is the centrist right. You have AFD, which is far right, extremists. You have SDP, which is center left. You have the Greens, which are the Green. You have the left, which you won't believe on which side that party is. And then you have the South one, which actually I don't even know this one. I know why it's included. 0.15% of the vote. I know it's there. But there were some other parties that also would have gone here, but they've been excluded because they didn't get enough votes. Right here, I suppose. What happened? Oh, because they won majority in one, but they didn't get in? That probably might be it. Oh, I know this country. Hi, the Theo. Oh, no, actually. Unfortunately, Theo, don't mind that. We're just talking about your country's politics. It's fine. Behind your back.
How would Theo know this country? That's a mystery.
Going to university and stuff improves your chances to get a job, but wanting to go into academic research substantially decreases it.
Where I go, they recommend you to they ask you what masters you wanna pick, and they will suggest you a curriculum. For example, if you wanna do biochemistry master, they will suggest you a biochemistry curriculum, but it's still better than being forced to pick between biology and or chemistry. And if you just don't wanna follow any of this and wanna go bananas with this thing, you can do that. You might not be accepted for masters anywhere, but you can do that.
Make it 10 to Hydra. I don't know what you mean, David. Hi, the Santos. Congrats on 750 days straight. Well, I tried doing it for 750 days straight. Didn't manage to, but you know what? At least I tried.
People who aren't familiar with your jokes will think that you have accidentally skipped a few days.
I did not, in fact, skip a few days. I did
Not
do it.
One.
Discord may go pop up occasionally on stream. I know. Ah, boy. And it was actually pretty nice special, wasn't it? For 750. I think it was a cool special. Now all I need to do is think of something for 800. I have this song playing in my head, just... Okay, this, same. There. Now, to walk, donate your organs. Check stream chat. Wait, stream chat? There's no new messages though. Which, wait. General, the one in streams. There's no new messages there. Oh, you meant Valve, okay. Now, what next? What's next? Yes, right. This right here will need a bigger radius, which I mean is done this way. I love how I sometimes make these geometry notes for myself and I have to guess what they do. And then vector math, add
Apparently, because of the title, YouTube thinks that you're playing Doom in this stream.
Really? How can you tell?
A meme channels, memes channel.
Oh, I am incredible. Oh, I guessed my own notes correctly. I am just fantastic. Wow. You should all be impressed.
I'm impressed.
Good, you should be. .77, then this plus 0.2. Okay, that works. And then these same one except minus 0.4. Minus 0.4. Oh yeah, it doesn't work because the piss. Okay. Vector math.
Why did I read homomorphism as homophobic?
What a question. No, that's wrong. This, and this. And then right here, there should be red, green, and blue. Oh, lovely. There we go. Anyways, to go back to the message, this file can be discussion. Make it a child as a homomorphism from an open set of a manifold to Rn. So I don't think they do it in primary school. Maybe in your primary school. I don't know. Oh yeah, I think the French educational standards really fallen. Honestly, if they don't do that in your primary schools. And clearly. Honestly, I feel like France needs to invest more in public education, because if even something as simple as a homomorphism from an open set of manifolds to Rn isn't taught in primary schools, then mate, that's rough. That's really rough. Almost as bad as America. I do have to say, if I ever become like an activist for public policy, it will probably be to increase the public research money, and then everyone here won't have to worry about getting a job as a researcher.
Yeah, I also agree that there's extremely low amounts of money that is given to research.
I wouldn't say extremely low amount of money that's given to research. I would say there's really there isn't a lot of money given to researchers. I would specify this way. Like, research is getting a fair bit of money. It's just that researchers don't get most of this money. And then every single paper is then stuck behind a paywall because, of course.
Yeah, it's way too corporate. Like, this is something that is that is meant to be beneficial for humanity and for the future and for all of us, and yet they are making a capitalistic scheme out of this.
Wait, no, that's too political.
All right.
No, my beard is growing back. That's nice. It's the nicest feeling when you need to think and you just like stroke your beard like a wizard. But I shaved recently, so I couldn't do it, but fortunately it's going back.
I genuinely never thought of the fact that you actually grow a beard.
Yeah. I actually needed to update my body for this. The old version just didn't cut it, didn't have that feature. I'm glad they got the chuckle. It was a very dumb joke, but I'm glad they got a chuckle. Okay, Hilbert space. Fuck, that's what I need to research as well. Hilbert space. You have a beard? Yeah, I mean, if I don't shave, then yes. If I do shave, then no. However, I prefer not to shave. Because, as I mentioned, thinking when you're stroking a beard is just the best thing in existence. Grow it out to Gandalf proportions. Well, that's what I'm doing. Oh, anyone here knows? Oh, damn it! It's gonna be Reblox, isn't it? Ah, fuck! I'll have to use a French guy for this. I mean, Reblox. Reblox. You know how I like you a lot, and mate, can you like?
Right now, I'm trying to imagine you with a beard, and I just can't. Like, this is not like.
What do you mean? Okay, allow me. Okay, I can give you a picture of what I look like with a beard. Okay.
All right.
It's basically like imagine this.
Okay, that's fair.
I wonder whose photo Make It was gonna bring up. Mr. Beast.
Ben! Ben!
You're not
Ben!
him. What do you
Ben!
mean? What do you mean I'm not? I'm literally him.
Both Ninja and Made It has to be banned.
Then I feel bad.
Oh yeah, I have mod!
Oh yeah, tell me this one. I feel bad because I made it a joke about the Reblax, but then he didn't respond. Now I'm feeling I didn't mean it, Reblax. It was just a goof, just a joke. Okay.
But Made It, you should actually like shush, like you shouldn't tell Make It that I have a mod because it's like it's only for 5 minutes, so like don't tell
Yeah,
Make It.
I did give time in mod only so that he could like add the one link in chat. I just forgot to remove it, so unless I remember to remove it, Timon has the mod.
So maybe you guys like please don't remind me, Make It to do it.
Why is it linear in the first argument? I'm sorry, but that's dumb. That's so dumb. Is this mathematicians being mathematicians, or is it me being an idiot? I need my Reblax. Where's Reblax gone right when I need some help with mathematics? Make it. May you please remember to remove Timon's mod? Yeah, if I remember about it, I will. Don't worry, I have a great record of remembering stuff. I didn't respond because I waited for the question. Oh, no. Okay, I see. Well, I made a very rude joke and you didn't respond, so I thought you just left. But okay. Am I an idiot? But is it specifying that it's in the first argument because it is actually only in the first argument? Or because it works in both arguments, but it's needless to say that because it's symmetric? Because wouldn't it being symmetric also mean that it would also work in the second argument? The second one. The second one as the second argument or the second option of what I said? That it's not specifying in the first one and therefore the second one is done to right definition like that. Okay, I see. Alright. I thought I was losing my mind for a second. Second option was yeah. Okay. Okay, great. Then it is positive, definite for all vectors. For quality for all vectors. X times x is greater than... Okay, so basically square gets positive, right? Hold on. Form of a summary of vector space has the same sign, always positive, always negative. Okay, good. Alright, so we have the Hilbert space with the dot product like this. Try a definition asking for it to be bilinear and then say, oh, by the way, if something is linear in the first argument, symmetric, then it's bilinear, so that's neat. I mean, I guess it makes sense. It's just that specifying in the first argument is... That threw me off a lot. Operation on pairs vector the process satisfies these three points. Is it good to use Wikipedia for this? But I feel like for mathematics and in advanced physics and advanced chemistry, it's fine to use Wikipedia. But a lot of people don't like it, so I don't know. Given such inner product, a real inner product space, every finite dimensional inner product space is also Hilbert space. The basic feature of the product connects with geometries that relates affect an angle between limits. Careful, will exist. A mathematical series comes with vectors. It's absolutely convergent, provided the sum of lengths converges as an ordinary series of real numbers. Okay. So it is convergent if the... So this is convergent if this is convergent, right? Am I understanding correctly? Like if the lengths don't spiral off to infinity, then it will converge on a point. That makes sense. Yeah, because then you can just like... Okay, that makes sense in my mind, but I don't know if I'm understanding it correctly. So when you have these arrows, then they will eventually converge on the point, because in order for their absolute, like their lengths to be smaller than infinity, then it's an infinite sum, which means the length must get smaller and smaller over time. I don't know, I don't know if I'm understanding it correctly, but I'm imagining it at some point in the series, the length of each arrow would have to be... I'm thinking about arrows, vectors, whatever. Hilbert space, basically vector space with angles and lengths and a technical condition that you're describing, which makes analysis work well. Okay, I see. What do you call it when someone gets a huge tattoo of pi on their face? An irrational decision. We needed this. So it's because a series of vectors that converge absolutely also converge from L, the Euclidean space, in the sense that this. That makes sense. This after 0 as n after infinity, yes. Expresses the complete Euclidean space. That is the series that converges absolutely also converges in ordinary sense. Okay.
Wait, what do you mean not really? Like, are they not the same guy, or are you trying to make it?
The time delay really screws everything up, doesn't it?
Yeah.
Please explain Dirac delta function. Hold on, delta function?
Yeah.
Am I misremembering the... No, I am not. How do you want me to explain this? This is about as clear as it gets. I feel like... What do you want me to explain here? It genuinely stumped me for a second, because what do you want me to explain here?
I mean, if you wanna like cry about mathematics for hours, then you can talk about this function for hours. But if you're a
okay.
if you're a physics guy, you just accept that it looks stupid, but we can do math with it and just move on with our lives.
I am too like physics coded to understand why mathematicians would be upset with this function.
Yeah, same.
Funny enough, in the video that I am right now making about quantum mechanics, quantum field theory, this segment actually, I discuss the difference between mathematical waves and physical waves, as I mentioned, which I don't think they are actual terms, mathematical and physical, but that is how we deal with waves in maths and physics. So, you know, in maths you have a cosine of x, which means it goes over all real numbers. However, in physics, you cannot have a wave that's just a cosine of x, because in order to have that kind of wave, it would have to go over the entire universe, which is not something that happens. So instead, in physics, the waves are localized, and right now the animation I'm making is about the curious consequence of that, where eventually, as you make the waves smaller and smaller, they kind of stop being a wave. Like, is this a wave? But then physicists just kind of close their eyes and pretend that it's a wave, and with the Fourier transform, you just get the wavelength, the possible wavelength, the possible wave numbers. And funny enough, this taken to the extreme, this would mean that you can treat the Dirac delta function as a wave. Like, as far as physics is concerned, this can be a wave. What's more, if I'm not mistaken, this would be if you have no idea how fast a particle is moving, absolutely no clue, this is what its position would look like. The wave function of its position. Which would be right after wave function call? I don't know. I don't want to go speculate that far, but this is what it would look like. And as far as I'm aware for photons, it is the opposite, where the wave function of a photon actually has a bunch of problems, and there are a bunch of problems why we can't really make it. And so one of these problems is the position operator. There we go. Largely irrespective of the proper wave equation, it seems difficult to define a position operator as usual, which is at the same time satisfies the commutation bit relation with the total angular momentum dictated by the French name, I'm not gonna pronounce it, symmetry. Look at me being so smart and educated and knowing stuff. Wow. Is that a good enough explanation of the Dirac delta function? Or shall I go more in depth? As I mentioned, from physics, not math, because I don't know that. That's what your brain can do when it's caffeinated. One of the easier French names, though. I don't know. No, I'm not gonna attempt. It's silly. Like, the E has a thing on it, alright? We don't need that.
Poincaré. Yeah, Poincaré.
I was not gonna pronounce it. I thought it was Poincaré or something. Poincaré. Or Poincaré. Or whatever. I don't care.
I think it's an A. Or maybe
often take. Okay.
Is it A or A? Like, is it the A or the A? The first or the second?
There's running the Euclidean space that series that converges absolutely also converges on inertians. Hilbert spaces are often taken over the complex numbers. The complex plane denoted by C is equipped with a notion of magnitude, the complex modulus, which is defined as the square root of a product of Z with its complex conjugate. If Z is equal to X plus this composition, right? The inner product, yeah, complex value of Euclidean dot product. Oh, that's curious. The inner product of a pair of complex numbers Z and W is the product of Z of the complex conjugate of W. Two-dimensional Euclidean dot product. Huh. I did not know that. Since I'm with space, C elements are pairs of consecutive numbers Z is equal to and the product is zero is given by. The real part of ZW is then the four-dimensional Euclidean. What? The real part whose elements are pairs of complex numbers. Yeah, the inner product of zeros. The real part is a four-dimensional Euclidean dot product, which you can use transcending complex conjugate. Oh, backwards. Oh, I see. Oh, okay. Oh, because you flip. That kind of makes sense. Hold on. I need to write this down to make sure I understand. It's because Z
yeah, is right.
W plus ZW is equal to WZ plus WZ this. Now we see numbers, whatever numbers, we all know what numbers are. And so then that flips again, makes sense. That's it, it's multiplied. Does it make sense? I'm gonna trust that makes sense. Real part is the four-dimensional product.
Reblux, when you have the thingy on the it doesn't does it only lengthen it, or does it change it to an A instead of an A in French?
honestly kind of wanna do a game or make it has to pronounce varying science people. I would prefer to do a tier list of them. I'm gonna be controversial and put Einstein and Grothendieck on the same tier, but I won't tell you on which.
It's just a vowel change, so it's all right. Because yeah, it's the same in Hungarian. Like we have and a, which is an with a thingy on it.
Of course, there's a backwards and forwards.
There's a and backwards a. Oh my god, and a with a hat. Oh my god.
Wait, we've gone over all of this. Oh, that was motivating example, definition, right? So, a Hilbert space is a real or complex inner product space. There's also a complete metric space, respect the distance function induced by the... well, this is rough, the phrasing is rough on me. With respect to the distance function induced by the inner product. To say that a complex vector space H is a complex inner product space means that there is an inner product xy associating a complex number to each pair of elements xy of H that satisfies the following properties. The inner product is conjugate symmetric, that is the inner product of a pair of elements equal to complex conjugate of the inner product of swapped elements, okay, the thing that we've just been over. This implies that XX is a real number. Yes, that makes sense, because it does imply that XX is a real number, because this has to be equal to it flipped, which only makes sense if the imaginary is 0. The inner product is linear in its first argument for all complex numbers a and b. Okay. Now I see how... Wait, is the first... Does the first matter in this case? Because the second one is... complex conjugated. The inner product of an element with itself is positive definite. Okay. Alright.
Can I have a question?
You can have a question, yes.
Thank you so much. What's the difference between, like, if you have these pointy brackets, what's the difference if there's a comma between the two vectors, and what's the difference if it's a not rod, what you call them, the standing line thingy between them?
There may be a difference, but at the same time, I'm pretty certain that this is mathematics, and I'm pretty certain that bracket notation is physics.
Ah. So it's just
linear algebra and linear operators on complex vector spaces. Okay, it is mathematics, but I mean, I have exclusively seen it in physics. I have never seen a mathematician use a bracket notation. Physicist... Bracket is also used in math. Is it really? I have never seen a bracket in maths. I've always associated just really liking brackets with physicists bragging that it's called a bracket, and that is a very clever name. But I have absolutely never seen it in maths. Mathematicians always separately is only physics though. Oh yeah, okay, then yes. This one. In this case, it makes sense. Hilbert space would make sense with the bar. So it probably... Wait, it might be the same thing. Hold on. I'm just studying this right now, Time, and I'm not gonna be able to answer questions all that well, but I'm pretty certain it would make sense if it's the same thing, because I mean, it is a fucking Hilbert space. Quantum states denotation... Yeah, in quantum mechanics, bracket notation is used because to denote quantum states. So the notation is for linear algebra and linear operators, but then quantum physicists just took it and use it everywhere in wacky ways. The inner product is a conjugate symmetry. Alright, so these are the three definition. That's what Remco gave me, if I'm not mistaken, when I asked him for when I asked him for the definition of a Hilbert space. I think that's what he gave me. Let me just check back on Discord. Oh, where's the int channel? There we go. Element of a Hilbert space. Space exactly in this form. Wave function might be new. Derivative. No, that is not the same thing. Never mind. XY, XY, and XY, all mathematician for the same stuff. Exactly. And you know when mathematics ends and physics begins? When you just start doing this. Which does not make sense. The inner product is conjugate symmetric. That is, the inner product of a pair of elements equals the complex conjugate of the inner product of... So, okay, so this is just... Hold on. Reblax. A Hilbert space is just... Because I need to dumb this down to make sure I understand. A Hilbert space is just a vector space that fulfills these few requirements, correct? It makes sense than vector and the covector, but we usually do it with start to sound smarter. Yes. I know not exactly, I know for a fact, plus the Hilbert part. Complex in the product space means that there's a product space. Wait, no, so these are the requirements for the complex Hilbert. Wait, what? So a complex vector space H is a complex inner product space, means that there is an inner product space. Oh no, this is the complex inner product. Oh, I am just been so played like a fiddle. Okay, Hilbert space is real. Okay, so the Hilbert fucking confusing. Okay. What's the definition of a Hilbert space? Am I going crazy?
It's so satisfying.
A Hilbert space is a...
Sorry.
No, do carry on. I'm just reading.
Because I'm supposed to know all this stuff, and I don't, but the fact that you're gonna understand it means that you're gonna explain it in a video, so I'm gonna understand it. After all these years.
What, is that the definition? The Hilbert part is when you add the analysis part, the thing is serious or corresponding with... Okay. Let's leave the difficult mathematics for when I at least grasp the fucking basics. Is this the definition? Hilbert space is a vector space of inner product operation which allows length and angles to be defined. No, it's not the definition. No, I mean, well, it's obviously it's not the definition. It's fucking, it's the first paragraph on Wikipedia. Obviously, it's not the definition. I mean, is that like what the Hilbert space is? It's a sentence like S squared is a rectangle. I know. Is that what the Hilbert space is? Is that like the defining characteristic? That's what I'm looking for. Before I go look for the actual definition. Why are there three of you? Because I'm trying to be productive. No. Okay, so what is the... I'm fine. So, there is a definition here of a complex inner product space. The completeness part is important. This. Complete space. Metric space is a complete venue for following equivalent conditions. Any, just one. Course sequence of point X has a limit that is also an X. Every course sequence of X converges in X. Every decreasing sequence, I'll leave the third one for now. A sequence of X, 1, 2, 3 of elements from X of a matrix space is called Cauchy if for every positive real number there is a positive integer such that for all positive integers, m and n greater than n. Okay, this seems understandable. So we have x, which is the metric space. Here you need not be a vector space, so you don't have the nice condition with series. Cauchy sequences are understandable. So, also that is not what I should be looking for. Hilbert space is a real or complex inner product space. Okay, complex inner product space is defined right here. Right, complex vector space is a complex inner product space, meaning there's a product or unique complex number, satisfying the following properties. So this would be the definition of a complex inner product space, which is what we're looking for a Hilbert space for quantum field theory. That is also a complete metric space with respect to the distance function induced by the inner product. I lost myself. I will tackle this in a second, but first, that is also a complete metric space. Completeness is basically, if a sequence looks like it converges, then it does. Okay, the name makes sense then. So we have x. I still should probably go over it. We have x. A sequence of elements from x metric space. It's called Coffee. Every positive real number. So we have some kind of positive real number that is greater than 0. And then we have an integer. And then we have two other integers that are greater than our integer. And then what we're basically saying is that d, xm, and xn is smaller than r. So we can basically, oh my goodness, this is simple. Oh, okay, so basically, we have a number. There always exists a number that's larger. All right. Yes, it doesn't spiral. If for every positive real number there exists no wait, it's smaller. No, I got backwards, didn't I? If for every positive real number, so we pick a number. So every single number has some elements that result in a smaller number. It makes sense. Now the complex in the product, it gives you a metric, distance between vectors. Then you have the specific metric space to be complete. Okay, when you have the complex inner product, it gives you a metric, distance between vectors. Makes sense. Then you ask for this specific metric space to be complete. All right. I mean right now, but I should come on the stream to explain. If you're eating, it's fine. This isn't, there isn't a fire. I should be able to get through this. It's not that difficult. There's also next. Okay, so basically, metric space set together with a notion of distance between its elements. Points. This is the measurement function called the metric distance function. All right. This is simple. Okay. Oh, this is so simple. This is so simple and easy. Fucking hell. So basically, we have this. We have this, which is like a set of. So this would be just, just like a set with a bunch of different, whatever, x0, x1, x2, x3, ... And then this is the distance function. So basically, what we're saying is that for a number that's greater than 0, we pick two numbers that are greater than, two integers that are greater than, or rather two things from that set that are greater than n, well, whose index is greater than n, and then the distance between them has to be smaller than this. Reblux, is this just... Am I understanding it incorrectly? But I may be understanding it incorrectly, but is this just kind of like creating continuity with discreteness? Because the way I'm understanding this is that if you have these 2 points, then what you're saying is that the distance between them is smaller. I don't know, xn. The distance between them is smaller than r, and in the definition it says that for every positive real number. So for every positive real number, there exists an integer above. Oh, hold on, wait, I think it just clicked. Okay, so I don't know if I'm connecting. Kinda. See, the rational numbers are not complete, but if you complete them, which thing you do, you get a real line. I don't know if I'm connecting the 2 completely unrelated dots or if I just understood why it's there. But because basically in here you are picking integers which are above a certain integer n. Not being complete is having holes. Okay. I don't know if I'm making a wild link that doesn't exist there, if I'm doing a conspiracy theory, or if I'm actually connecting a reasonable dot. But earlier on, when you had the thing with vectors, where it just converges, I don't know, a nice spiral like this, why not? Whatever, something like that. Then this would kind of make sense here, because you pick n, so you pick a vector of a certain index, and then what you're saying is that you pick a number r that's greater than 0, and then once you pick a number n, for each r there exists an n above which the distances between these two will be smaller than that number. Which means that if I have this kind of converging set of vectors, right? Then I can pick a distance like 0.25, and then once I pick that distance, there has to exist an index n from which on the distance between any 2 vectors will be smaller than the r I just picked. Is that what's happening? Let's check. Okay. A complete metric pair was specified to the distance function induced by the inner product. Okay, so inner product. Hold on, induced. Topology. Oh goodness, great. You can't escape having holes. You can't escape topology with holes. I think you're proving that the convergence sequence is Cauchy. You see, I really am proving that. Step 1. Assume that the sequence is convergent. Step 2, assume that it's Cauchy. Step 3, assume that the definition of it being Cauchy proves it. Congrats. The make it proof. Hilbert space is real or complex inner product space. There is also a complete metric space. Complete metric space being this one has a limit that's also every point in x has a limit that's also in x. So they're like 3D numbers. Wait, what? Vectors? Vector space. Oh, Stump. Mathematicians have this habit, which is extremely fucking confusing, where basically... So here's the thing, Stump, you know how... Because I've also been extremely confused about vector spaces, and it gets even worse the deeper you go into mathematics. You know how in physics, sometimes when you have an object that's like 5 kilograms, for example, then based on it, you can create a... to define direction. Okay, Stump, so basically, here's kind of why it's so confusing. You know how in physics, when you have an object that's kind of like 5 kilograms, then you can create a theory based on it, in which the object can just have a mass of m. and then the model will still work. Like, you know, you start with 5 kilograms, and then based on that you can just create like a general model for describing any object with mass. Basically, in mathematics, what happens is that instead of starting with a specific number, you start with some kind of like object, and then you like try to generalize it into just properties of this object. And so it's I don't have a good analogy because there isn't one. So basically in mathematics, you're more dealing with the properties of the thing rather than the thing itself, because you want it to be as general as possible. So two numbers set direction and one sets a property. Not really. It's more like, it kind of depends on what you're talking about, but it's more like, okay, abstraction, not the bad. Okay, so imagine that, what would it be? Something that would work with multi-dimensional vector. This is rough, there aren't that many things that work all that well. I'm trying to come up with a quick... I'm trying to come up with a quick example, but I can't. Okay, Stamp, think about it this way. Imagine that, because here's basically what a vector is. Basically, vector is just... it's not the exact definition. I can't give you the exact definition because the exact definition won't help. You should think of a vector as just multiple things in a linear way. So a vector would be just like x, y, z, w, ... Multiple things in like a linear way. Vector is like array. Basically, okay, so we have multiple things linearly, like this. However, you can use this concept to describe a lot of different things. So most commonly, as far as I'm aware, it is used in physics to describe an arrow. So it doesn't have to be free. It can be so much more than free, and I'll show you in a second just how far you can go. But starting simple, you can describe an arrow with it. You can describe an arrow like this, right? You describe an arrow in physics, and then you have one of these numbers to describe one arrow, and you have another one of these numbers to describe the second arrow. Like, yes, that's one example. And that's probably what you're thinking of when you say that vector needs 3 or 2 or 3. But then consider another example. So yes, you can have it with just 2 numbers. What's more, you can also have it in 3 dimensions with 3 numbers, which would look probably like this. I'm trying to draw a 3D space on a 2D screen, so you just have to trust me that all of these are 90 degrees between themselves. So they are more like coordinates, kind of. Well, now it's time for the big review, Stamp. Imagine, so right here, this is starting to make some sense. Well, I haven't even gotten to the twist. This is making sense, that's reasonable. But now imagine something different. Imagine that you are making a video game, okay? In which you have 10 players. 1, 2... I'm not going to draw all of them because, I mean, come on, that's ridiculous. 10 players, like this. And each of these players has some amount of health. So like this one has 10 health, this one has 11, this one has 7, this one has 5, this one has 3, this one has 2, this one has 13, this one has 17, this one has 23, if I'm not mistaken, and why not, this one has 1. Okay, you have this video game with 10 players. What you have to realize is that if you take all of these numbers and if you package them in a linear way, then what you have created is a 10-dimensional vector. Because this is a vector with 10 numbers. Therefore, it is a 10-dimensional vector. And basically what mathematics is all about is creating concepts that are as general as possible. And the reason why it's so important is because once you create a theory which can describe these numbers, then if you can just describe these in terms of a very general property of, just multiple numbers, then that means you can use the same exact theory to also operate on these numbers. And so that's why accounts to position vectors to properties. No, the thing is, vectors describing position is just one application of a vector, but you can apply it to anything. That's why this is a genuine, honest, and true 10-dimensional vector. This is what a 10-dimensional vector would really look like. So basically, linear algebra gives you like a method for describing multiple numbers at the same time. There is the asterisk that they have to be linear, but that's a story for another time. And so linear algebra gives you just 10 numbers describing anything. Well, that's the point. X numbers describing anything. You can have any amount of numbers describing anything. So if you just think of an example of multiple linear things, each described by a separate number, you can use linear algebra on that. And so that's why vectors can have as many numbers as you want. What's more, the example I always go for is programs. That's because programs usually store a lot of data at the same time. So when you think about it, when you think about an image, for example, then if you save an image in a funky way where it's going like this, like you're saving each pixel, then you can think of an image as a single vector with like millions of dimensions. Even infinite amount of numbers describing stuff. Yeah, that's the whole point. That was the next thing I was going to get to, which is that basically you can... we could make an algebra of this. So do they all have to describe the same thing? Well, here is where we get to the limit stump. Basically, what you have to realize is that in mathematics, you are not restricted to anything other than reason. And even then you can be flexible. So basically, the way linear algebra is often like described or explained is with arrows. But then what you realize is that you are not actually confined to visualizing them. You don't have to think of vectors as arrows, you can just think of them as numbers. Then what you realize is that you don't even have a finite amount of these numbers. You can have an infinite, and you keep going and you keep going. So they don't have to describe the same thing, but there are still limits. You have what different vector spaces basically are, is every single different vector space gives you like a different definition of what that vector space would be. So for example, even though right here we have a 10-dimensional vector space, and right here we would have a 3-dimensional vector space. I love this quote. Yeah, you're welcome. So right here, you would have a 3-dimensional vector space, 3 numbers. Right here, you have a 10-dimensional one. They would still probably be different vector spaces. That's because we would have different rules between them. So, for example, in the health vector space, I don't think product would make much sense. Like the inner product, for example. That wouldn't make much sense in the health vector space. That's why we could probably define this health vector space without actually having an inner product. In this case, we would like an inner product for obvious reasons. That's how we use them. And so on and so forth. So basically, a vector space is just the general concept of having multiple numbers. And then the specific kind of a vector space gives you the additional definitions based on what you're working on. That makes sense. I'm really glad then, because that's not an easy topic to understand. This is generally... You don't really see math being taught this way unless you really like math. Mixing is kind of like all the mixing console, the faders. Yeah, they can describe anyway. So, and looping back actually, type of vector space is determined by the axioms that it follows. Yes, exactly. And so in this case, what we have is a Hilbert space, which has its own definition, which you can see right here. This is the definition of the Hilbert space. And so it is different from any other space because it has a different definition. However, like the underlying concept is... And so that's what I'm doing right now, actually, Stump. I am right now trying to get to the bottom of the definition and figure out exactly what it is. Jeez, this is mathematics, huh? You know what? I'm actually gonna screenshot Roblox quoting me because I am vain and a mathematician quoting me on mathematics. That is really floating my ego. So thank you for the explanation. Well, I'm glad I could explain the basic concept, but I haven't actually explained how you'd use any of them. Basically, this is... In mathematics, it goes different to how it normally goes in other fields of science, because in other fields of science, you get more specific. So in chemistry, for example, you start with the general rules of reactions, then you get more specific. You ask the question of why do these rules happen? Then you get even more specific. You ask why these underlying rules... like what causes them. You get even more specific. You start talking about wave functions. You just go more and more specific. In mathematics, you go the other way. You get more general. You try to create rules which like span everything. Vector spaces are an advanced topic. Now they are seen in FSU math degree, so advanced topic, but real advanced math they're not. Yeah. Might tell you about how math gets deep fast. That's another thing. Most people on this planet have never seen advanced mathematics, because why would they? I really like the meme of the one you shared Roblox with. As a mathematician, there are 10 other people on the planet who understand what you do, and none of them have the power to fire you. Specific people in math also. Some people spend their life studying one specific instance of an object. Yeah, but even then, the object, it's... I don't mean it that way. I mean, like... You... Instead of the definition getting more and more precise, instead of definitions becoming difficult by being more and more precise, they instead become more and more difficult by becoming more and more general. Which is what you would also want in science, by the way, is just that in science we're just not there yet. Like, that's the whole point of the theory of everything. You want to add a theory that's as general as possible. But to an environment of p-adic numbers or modular space of curves or a force sphere. Yeah, but that's actually what I mean. Like, in order to understand the 2x2 invertible matrix of a p-adic number, you first would need to understand what a p-adic number is. And that requires you to develop an extremely general definition of a number, or rather, to develop an extremely general concept of a number. Mathematicians, I've said it multiple times and I'll say it again. Scientists need subsidized weed. Because you cannot. Can you have a negative vector? What do you mean by that, Stump? You mean, because, like, there is a lot of ways in which the answer would be yes, and there's a lot of ways in which the answer would be no. Like, for example, you can have this, you can have this, you can have this. Would you have 1, -2, and 4? Yes, actually. Yeah, you can have negative numbers inside the vector. I don't know how to say it. It's fine. It's fine. I get it. It's specifying is also difficult. Like when you want exactly what you mean, because there's a lot of possibilities. But Stump, you know what's even more fun? Some people are trying to answer specific questions about specific objects and usually why we invent abstract stuff in the first place. For example, Kyle more or less came up with the groups when trying to prove polynomial equations were unsolvable. so mad, by the way. Does photon speed depend on source or have something of fiction? Stuff like so it can be dependent on source of light and distance between A and B. I don't quite get your question, Kenshi, because do you want, like, crazy story? The speed of light is constant and it's always equal to the speed of light. You and see. What was I doing? Oh yeah, right. Hilbert space is a real or complex inner product space that is also a complete metric space with respect to the distance function induced by the inner product. Induced, a subspace, okay, induced. Why is induced highlighted? Oh, because
Like everything that doesn't have a mass travels with the speed limit of the universe, which includes light, because light doesn't have mass. But like it's not the light speed that is special; is that is the nothing is slowing it down, so it travels with the speed limit, and everything that has mass is slowed down by mass, so they don't travel with that speed.
Okay, so the topology induced from that of X. So it has the same topology as the distance function induced by the inner product. Name topology, don't hurt yourself. But I want to know what induced means in this respect, and they link topology for some reason. Is a real or complex inner product space that is also a complete metric space. Okay, so I got everything. The only question is, what is the distance function? Because I need the distance function to figure out the complete metric space, right? So complete metric space is just a space that has that is complete. It's just a metric space that's complete. And a metric space is just the space of elements, hold on, set together with notion of distance between elements. Okay, so metric space is just a set of elements that has the distance between them. By the way, I am a bit insulted, Stump, though. I really am, because I have made a video called Let's Do Physics in 7 Dimensions, in which I explained vectors, actually. I explained that what they are. I also even explained matrices there. Complex inner product, you can use them to get the norm of any vector size. A distance function by setting... Okay, so the distance is just the distance. Okay. Oh, right, so the complex inner product gives you the magnitude of the vector, and then the difference in magnitudes gives you the distance. Wait, does it? Hold on. No. I misunderstood. Distance is just the difference in vectors. So, oh, you get the difference in vectors, and then you get the magnitude of the difference. Okay, that checks out. That actually makes sense. Okay. Oh, we got there in the end. Hilbert space. Damn it. Make it. You do realize that you have 819 videos. Gemma. 819 minus 752. I have 67 videos that aren't lives. What's more, I also have around 20 or 30 shorts, which gives us like 47 videos. What's more, if we can reduce also the alias on Sack, so we can also reduce them. I have like 27 videos that are worth watching. Personally, I only watch about 200 of them. I have no idea how could you possibly watch 200 if I have only 40 something videos. The mathematical material in this section can be found in any good textbook on functional analysis. Okay, may I have the... Oh no, wait, you want... right, because any good textbook on functional analysis, huh? Fine. Yeah, I always misspell analysis because it's dumb spelling. What am I looking for exactly, first of all? There's complete metric space with respect to the distance function induced by the given product. I want to make sure what the distance function is. I need to know what the distance function is. This must be one of the longest streams I've ever done.
Really?
Yeah. It's mathematics. They're always the longest ones.
It's only been 1.5 hours.
Time dilation.
I see.
Yeah, I came here for Doom gameplay. I don't have enough money to do Doom gameplay. It's a very expensive game. The distance function is square root of SQQ. What's SQQ? In the product, certain complex number to each pair of elements. Point properties, false property on the complex. I should just read ahead. It might be there. In the product space, values, volume of a dual system. The norm is the real valued function, this. And the distance between 2 points, would you look at that? It was there. I should have just read ahead. That's the norm. And that's the distance. Oh, so it is correct. It's just that... Okay, never mind. I was... Alright. Okay, so I was thinking about it correctly. It is just the difference between the vectors and then the magnitude of... I know it's not. It's norm. All right, I should use the proper names. Can't wait to find out how much money you need to charity. I can just tell you because I know. With the power of foresight, I know how much money I donated to charity. A fair bit. I know, Theo. I read them, but I've been busy thinking about what is in this specific case. Hold on. Okay, great. We got there.
I just connected the dots that the reason why you can read so fast is probably because you have to read the entire chat between 2 lines of thinking.
I just paralyze. I think and read at the same time. Busy thinking in this society, in this economy. What's quantum entanglement? As far as I'm aware, actually, quantum entanglement isn't, unless I am misunderstanding a bit, but I don't think it's that interesting. It's when you have a single wave function to describe multiple particles, I think. I don't remember. And then basically when the wave function collapses, or both of them have to collapse, I think. I don't remember. Haven't gotten to it yet.
What do you mean it's not that interesting?
It's not that interesting.
It's hella interesting.
Antiparticles are interesting. That's cool.
I know I'm interesting.
I didn't even connect the dots.
Huh?
I didn't even connect the dots that you're like positron.
Yeah. And people who don't know my Discord name are probably confused right now.
Wait, did I even need to like research all this? Hilbert space. According to protocol mechanics, the wave function can be added together, multiply common numbers to new wave functions, and form a Hilbert space. Oh my, makes sense. That checks out actually. Yeah, that actually checks out. Okay, that's pretty. Okay, so I got the Hilbert space knowledge in me now. Cool. Is the omnipotence helping? Yeah. Bye, siphon, bye. See ya. Parallel processing. My brain is a GPU. What makes something interesting to you? It's when the theory is curious. Hold on, I don't know how to put it in words. It's basically when you start with a very simple assumption, and that leads to a very counterintuitive consequence. Or rather, the solution, or you have a problem and the solution is wildly creative. Something you wouldn't think of. That's when things are interesting. That's why superposition is, I think it's like one of the first assumptions of quantum field theory, or rather the first things, you know. So that's not quite as interesting as this. I like this so much. I actually started on my browser just to. But yeah, this is basically a textbook which goes into why antiparticle exist, and that is just, and I absolutely love this because basically the idea is that you have the energy. I've explained so many times, but it's great. You have this equation. Not really, because in reality, I'm pretty certain it's, I mean, a square. Not really. I'm pretty certain there's also plus PC square. I think square. I don't remember. But the point is, you have this equation, and then you want to figure out what is the energy, and so in order to do it, you root it on both sides. But when you root it on both sides, that means the energy is equal to plus minus mc squared. And this is like wild, because how would you get this to be negative? And you just end up with this, which is in Dirac C. It's a curious topic. I will get to it eventually when we're done with quantum field theory and I start going into nuclear physics.
Make it. I think I have officially overthrown your channel.
What do you mean?
Gemma's comment
Where?
in live chat.
Oh, I got so used to hearing a time on your stream that I accidentally searched positron on YouTube and still make it to check if you're live. Superposition is the time span where the veggies are not soft, but the broth tastes amazing already.
Now I want soup. then get some soup. I mean, I could like spend hours on making some soup, or I could just make me some instant noodles, but I don't want like the instant noodle soup. I want real soup right now, and that takes a lot of time to make.
This sounds like something Reblax would say. The separable Hilbert space being considered is infinite dimensional. There's no finite set of squarable integrable functions which can be added together in various combinations to create every possible squarable integrable function. Wait, so vector space or wave function has infinite numbers? I don't think so in this case. I think this is more about how you want the superposition to create a wave function, but you want them to be unique. Does that make any sense? I'm still reading.
Yeah, but to get the ingredients of the soup, first of all, it's a lot of time to chop vegetables up. Second, I'd have to go to the store and stuff. I'm saying this to Theo.
The particulars of the time. All values of the wave function are components of a vector. There are uncountably infinitely many of them, and the integration is used in place of summation. Okay, so what you do is take this, and then you add every single. It's dumb.
Always eat outside when you're hungry. Like, Jesus Christ, that must cost a lot. Like, eating outside every time. Also, Theo, you are always allowed to come over and make some soup.
Wave functions. You know, I think I might be it for this stream. So nice, no wanna. I really need to try out my course next year, so I do my PhD in Paris, and I can live with my parents. It's much easier. PhD in Paris. Dr. Reblax will also go Harvard, I do have to say. It's wild to think that in a couple of years we're just gonna it's gonna be doctor everywhere. I'm gonna add a genuine rank on Discord called the doctor. It's gonna happen. Anyway, I am gonna go now. I need a break. I need a break, and I need to script the video some more. And so for now, I suppose that'll be it. Thank you everyone so much for watching, and have a great day. Bye.